see how that works. All right. So, why don't we get started? Cool. So, today I'm going to talk a little bit more about Agile practices and really try and kind of drive home the link between going from an individual to a group and why Agile practices sort of gives you as much as possible of this speed that you have as an individual coder, even when you're working together with a lot of people. All right. So I put an updated programming assignment handout on the web page. Basically, I got a bunch of questions in the last couple days and tried to fold in all of the answers to those questions. I didn't do anything to change the way grading would be done or anything like that, but it's just sort of advice on what types of things you're going to be using, etc. And I've also created a slide to that effect. And I guess the most important question that popped up a number of times was whether that first assignment was to be done individually or as a team. And it wasn't perfectly clear in the handout. So just so you know, it's an individual assignment. But think of it as a way that you're going to present yourself to the rest of the class at some level, because this first assignment is maybe a way that other students are going to find you and join into your team or participate in the project that you're working on. All right, and that's due a week from today. The focus on Tuesday was about testing, and really what I wanted to drive home, and if there's one thing you remember about testing is that it really expands your reach as a coder. It expands it through time because those tests are things that are maintained much better than your own memory. And it expands it through space because it allows other coders or other users of your software to understand what it is that you're driving at when you're writing. It's what you could call a force multiplier. It really increases your ability to make your code useful across both space and time. And just as a reminder, Office space and website. So, I think we've covered that, but just for reference. I've already mentioned a few of these things. You'll be submitting your work individually. We're in the process of making a decision on the repository. That should be set up probably over the course of the... Great. And there were some questions about whether to use JUnit or not. I didn't really talk about testing with JUnit specifically in mind. There are a few others, but I do highly recommend JUnit because there's really good integration in Eclipse. And the reason I'm mentioning JUnit 3 versus JUnit 4 is that GWT at the moment, GUID, doesn't really support JUnit 4 very well.
Are there going to be details online on how exactly we should submit to Git for our project?
Yeah, I'll have to write the grading script.
Okay.
Submit the script and then I'll
Okay, so we're going to submit through a script?
Yeah, I'll try to do that.
All right.
Yeah. Cool.
Okay, and then the other thing I wanted to really stress in this is that I'd like for you to sort of talk a little bit about what you'd like to do, in your programming project. It's obviously if there's a specific project that you have in mind, all the better. But even if you don't, there might be a technology that you'd like to do, or a particular type of mashup, or a particular library that you'd like to explore, or a particular existing service that you'd like to expand. So we'll take a little bit of time at the end of the class maybe to just sort of talk about programming projects so that you have an idea of what you might want to put in these 1 or 2 paragraphs as you submit your assignment. And another thing to think about that's not usually something you might think about in a CS class is that those paragraphs could serve as a pitch to other students, for your project or your ideas, or to work with you. And obviously, the creativity of the code you submit and the kinds of things that it does can also serve as a pitch. Letting people know that it's going to be a whole lot of fun to work on this project because I'm doing this, this, and this. Okay. All right. So I'm going to every now and then always come back to this notion of thinking big. And I think that when we think about scalability in terms of hardware and stuff like that, it's a lot more obvious. But since we're going to be talking about people, I wanted to start by using an obvious example and then working in people scaling afterwards. So not too long ago, Toshiba announced a flash memory module that's about the size of a thumbnail that has basically a 500 billion bits in it. And I was like, wow, that's pretty impressive, 500 billion bits. Last week I put a slide up of $100 trillion bill. So I had $100 trillion in my pocket, and I just thought I'd show it to you guys. I went and got one of these bills because I thought, this is too mind-blowing. I have to have one of these. And then when I got it, I was like, wow, I'm holding 100 trillion of something. But it's really not 100 trillion of anything. Go ahead.
How should you pay for it?
Well, actually, it was offered to me by, I went to a coin store and I said I was teaching a class about scalability and explained, what it was all about. And they said, oh, go ahead and have one. But they were going to charge me, $20 before I explained. So, actually what's really funny is that they had a stack of $1 bills that were printed about a year before this. And those $1 bills are worth a lot more to collectors than the 100 trillion